Welcome. Full disclosure. It is late. It is after midnight. I've been doing these videos for like 5 different preps all night. I'm pretty tired. I think the last time I did one of these videos, I was so sick, I felt like I was gonna die. And so you guys have been treated with some very interesting test reviews. But here we go. We gotta push through it. I gotta get to bed. Let's do it. The main focus of this test will be probability of events, Venn diagrams, conditional probability. This test may also include measures of tendency. Okay, whatever. I'll give you full disclosure. I wrote this test today, this test review. I've seen all these questions before. I'm going to pretend a little bit like I haven't. I was feeling a little in some kind of weird mood when I was doing these, and I got some funky questions for you guys, so I'll try not to laugh at my own jokes. It is a dangerous life for wildebeest in the Serengeti. If a wildebeest is born in the first 4 months of the year, it has a 60% chance to survive the first year. However, if a wildebeest is not born in the first 4 months of the year, it only has a 35% chance to survive the first year. What is the probability that a wildebeest will be born in the first 4 months? Okay, so we've got one of these kind of pathway questions, right? We got wildebeests. Strange that it's beasts with 2 E's, but I didn't name it, I guess. We got these 2 options, right? We got the first 4 and the last 4. I'm going to call this F for first. And the odds of that are 4 out of 12. Then we've got the last, which is going to be 8 out of 12. And I know that because it's just months. That's going to split into survive or die. The first 4 will survive with 60% chance. It's like 6 out of 10. So die 4 out of 10. So they have a 35% chance. 35 out of 100 divided by 5, it's going to be 7. 7 out of 20. Survive 7 out of 20, which means it will die 13 out of 20. Okay, let's do these questions. What is the probability that a wildebeest will be born in the first 4 months but will not survive its first year? That would be first 4 months die. That is one event going to be multiplied 4 over 12 times 4 over 10. So easy, I can do it in my head. 16 over 120. So easy, I do not want to simplify it in my head. 16 over 120. Math, enter. 2 over 15. Obviously. Sweet. B. What is the probability that wildebeest will survive its first year? Do I have other colors? Surely I have other colors. Got this green. Survive. That would include this survive and this survive. And those are 2 different events that would need to be added together. That would be 4 out of 12 times 6 out of 10. That's this leg plus this leg over here. 8 out of 12 plus 7 out of 20. So easy. No. 4 times 6 divided by 12 divided by 10 plus 8. Oh, I wrote a plus. That needs to be times. Divided by 12 divided by 20. No way. 2/5, 40%. Interesting. Numbers. Crazy. I don't know how that worked. That's crazy. Cool. C. Given that a wildebeest will survive its first year, what is the probability it was born in the first 4 months? You know what? We've got conditional. Because this is saying that it is given that the wildebeest will survive, which means we do not need to count any of the odds that it will die, because we know for sure it's going to survive. And since B, we just calculated how much it will survive, the way conditional works is the conditional is the bottom, 2/5. Given it will survive, 2 out of 5. What is the probability it will survive its first 4 months? Okay. Well, the first 4 months would be the odds that it did this and then this. We know for sure it will survive, so we only want to count when it survives. So 2 out of 5 is our denominator. That is perfect. The numerator, given that a wildebeest will survive its first year, what is the probability that it was born in the first 4 months? Well, I guess it's just going to be 4 out of 12. Interesting. So 4 times 6. Hold up. I had a typo. I knew something was wrong doing this freaking midnight. Alright. We had a typo. Caught it. Right here. It says 4 times 6 divided by 12 divided by 12. I knew that should not have been so nice. One of these is supposed to be a 10. Alright, there we go. This ain't right. 13 over 30. Much uglier. That's what we want. So that means this should be 13 over 30. So now what we want to do is consider what the probability is that they've survived if they were born in the first 4 months. So we want to put the first 4 months on the top. 4 over 12 times 6 over 10. All right, let's do it. Alpha y equals enter, alpha y equals enter, times alpha y equals enter on the bottom, alpha y equals enter. Alright, 4, 12, 6, 10, 13, 30. 6 over 13. The reason it is 6 over 13, and it kind of comes out of nowhere, is you can't just say that it has 4 out of 12 chance of happening, because at the end of the day, this looks like it has slightly less chance of happening than this. Even though we think, oh, well, you know, it's 6 out of 10, that's above half, and this is only a 7 out of 20, but remember, this is a 4 out of 12 versus 8 out of 12, so actually, most of the probability is over on this side. Surprisingly. More wildebeests would survive in the being born in the second half, because there's just more wildebeests being born. Interesting. Alright. We're going so slow. Oh my god, I'm never going to sleep. Here we go. Cumulative frequency. 200 students were asked about their daily exercise and 144 answered between 0 and 60 minutes. These 144 students had their data graph below. So what is this 200? Why did they say that? Okay, whatever. Fill out the data table organizing these students. Okay. My N is 144 because they told me 144 kids, and that would be all of these frequencies added up. Now it does look like this is a little bit tough to tell. So if this was graded, you would probably be allowed to have some different answers, but importantly, it has to add up to make 144. That's a non-negotiable. So do your best. I would say that's probably 10, which means my cumulative frequency is going to be 10. I would say this next dot is probably 29. So if that next dot is at 29, that means there's 19 in this category. I would say this next dot is probably at 59, which means that there would be from 29 to 39, 30 people in that category. This looks like, that looks kind of right on it. I'm going to go with 90. And that means that there would be 31 people in that category. And this looks like a little short. Maybe we go with another 9. 129. Which means there's 39 in that category. Wow. It's huge. Okay. And then at the end here, we know when it has to stop, right? It has to stop at 144. So that would mean we had 515. Now I'm gonna make sure, I'm just gonna double check this because we could really mess this question up if this doesn't add up right. 10 plus 19 plus 30 plus 31 plus 39 plus 15. 144, okay. I think it's good enough, right? I mean, maybe we're off by one, but this is a hard graph to read. They have to allow us some leniency. The other page says, find the following measure using the cumulative frequency graph. The median. The median is the middle. The median is n plus 1 over 2. So that would be 145 over 2. So that would be 72 and a half. So I'm going to look at 70, 80, 75, 72 and a half. That looks nice. It's perfect. 35. I think that's good. 35. The modal group is basically the mode, but it's the group that has the most, which would be this 39. It would be from 40 to 50, but I don't think we have that equal sign. Sloppy, but I'm tired. We're going fast. Q1, Q3, IQR. Okay. Well, Q1 and Q3, now that I'm split and I've got 72 before and 72 after, I would want to look in the middle of that. I would want to look at my 75%. Maybe I could even just use a calculator to figure that out, right? If I've got 144 and I want to find my quarter mark, it would be 36. Or I could think about it like half of 72, which is 36. A couple different ways to figure it out. So Q1 is 36. Q3 would be 75. 144 times 0.75 is going to be 108. But remember, those aren't really the numbers I want. That's like the person that I want. So how much did they actually use daily exercise? So 108, 105, 110, 108. I would guess like 44, I guess. 44 minutes. 36. I would guess probably right in the middle there, 22. I'd probably go 22. And the IQR, you need to subtract those, and I would get 22. Easy. Obviously, if this was graded, you'd be allowed to have a little bit of leniency here. Not a whole lot, right? I mean, you couldn't put 50 minutes. It would have to be 44, 45, or 43 probably. Find an estimate for the amount of daily exercise that 75% of the total student body I'm seeing now. The total student body is 200 kids. It's 200 kids. It's not just 144 because a lot of those kids are saying that they exercise for like 2 hours, I guess. So find an estimate for the amount of daily exercise that 75% exceeds, which means 75% are higher than, which means we're really looking for 25% of 200, which is easy. It's 50. So 50, I'm looking for that kid that's at 50. Here's 50. Right here. I would probably say 27. 27 minutes. I'd probably say 27 minutes. 75% of the school is doing more than 27 minutes. The bottom 25% are doing 27 or less. Everyone else is doing higher than 27. A little bit funky with that 200 thing. I like that. I think I've ever seen that. Venn diagrams. Easy. Can't embarrass ourselves. Use the Venn diagram to find the following probabilities. U equals 80. Let's freaking double check this. 19 plus 11 plus 13 plus 1 plus 6 plus 9 plus 17 plus 4. 80. Whew. Not B means we should not include. We need 80 take away 11, 13, 6, and 9. Get rid of all the B's. And I got 41 out of 80. P-Cub, probability of C or B. That means anybody in C is good or anybody in B is good. Do not double count those middle ones. 11 plus 13 plus 6 plus 9 plus 1 plus 17. 57 out of 80. The probability of A and not C. You must be inside of A. And you must not be inside of C. So I need to exclude 1 and 6. I only need 19 and 11. 30 out of 80. Conditional not B. Considering that you are in C. So this is not really all that complicated. C. So we're only working with the C. We can ignore everything else. We only have the C. And given that, what's the probability that you are not B? So, remember the conditional is going to change the denominator. We've got 1 and 9 makes 10, 27, 33. There's only 33 kids in this question. And not B is going to take away those two. 18. That's easy. Okay. Use the Venn diagram to create probability notation questions that would result in the following answers. Ooh. Interesting. Okay, 30. How can I make 30? I can do 17 and 13. That's going to be complicated. Okay, here we go. 19 and 11. I want to do this one. So that would be the probability. I guess these don't have fractions. Maybe these need to have fractions, right? Or maybe they could say n. Like the number. Okay. So this isn't quite good because they need to have fractions. I need to edit this test review. But I'm going to go for this 19 and 11. I'm going to say that you have to be in A and not C. Have to be in A and not C. 17. Okay, here's just a straight up 17. That could be you have to be in C and not A and not B. Oh, 17 is right here, 11 and 6. That could be you have to be in A and B. That's easy. 37. What is 37? Oh, it's the easiest one. Huh. 30, 7. Is that what they meant? That's so easy. Too smart. Use the Venn diagram to find an alternate probability notation that asks the same thing as A conditional B. Well, what is A conditional B? A conditional B means we're starting in B and all the A terms. So that would be 17 out of the B terms, which is 39. Okay, what about this other one? You have to be in C, which is 10, 27, 33. And you have to not be in B, which is 18. Now I don't think it says that asks the same thing, which means they want the same question of A. We want to choose this. I think that's just about the only way to say it. You're in C, but you're not B. Maybe we could get weird. Alright, you're in C. I don't know that I like these questions. Maybe I'm dumb. Maybe you can figure out a way. I think that the bottoms here is what makes it really hard, right? Because we have to choose the same thing. We have to choose conditional B, right? It has to be like this. And if it says A and we want these terms here, only considering B, which is these terms, we could I don't think there's any other way to say it. I mean, maybe we could say like something stupid like this. You have to be A and B, but it's like we're already guaranteed. Okay, here's this stupid thing I came up with. A and B, conditional B, which is so silly because it already says A, conditional B, and all I did was put an and B there, but I already know that I'm already in B because that's what the conditional is for. I don't know. Maybe we'll just do this. He cheats. All right. Oh my God, 2 pages left. A magician has a trick where she flips a coin and it lands on heads 6 times in a row. Actually, she doesn't have a trick. She just flips a regular coin like normal and hopes that it works. What is the probability that her trick is successful? Man, she's good. Well, it would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. 1, 2, 3, 4, 5 times 1/2. Or if you're smart, you could write 1/2 power 6. 0.5 power 6. The probability is 1 out of 64. Good luck. The same magician is sick of looking silly. She develops a coin that will land on heads more favorably 55% of the time. Any more weighted and it would be too obvious. How much has her weighted coin improved her probability of success? Well, 55 is 11 out of 20. So it's literally just the same thing, except for we need to do 11 out of 20 6 times. Which is 0.55 power 6. Oh, turn that into a fraction. Well, it doesn't want to make a fraction because the fraction has too many bars. 0.02768. I guess that is probably okay because it says how much has it improved, which means what we really want is to take this number and subtract the answer from A. Take this number and subtract, scroll up until I get this answer from A. The answer that they want is it has improved by 0.01. She might have to find a new job. Improved by probability of... I'm off screen again. That is not very good. I think she's gotten a 1% luckier. Okay. See. What's she gonna do now? What is her probability of success? Oh wait. The same magician still can't find her rhythm and is desperate for more success. She decides that if she gets heads at least 5 times, it's still an impressive trick. Move the goalposts. This is great. She will still use her weighted coin. Okay, so that means that she's going to do 11 out of 20 5 times. But she is going to get unlucky once. 9 out of 20. 0.55 power 5 times 9. Oh. Times 9 over 20. Alright, she's got a 0.02642264. She's less likely, but shouldn't she be more likely? Because she's going to take, and what's happened here is, remember, she's getting heads, tails. But there are other legitimate ones, like heads, tails, heads. So this tail can move its way into position 1, 2, 3, 4, 5, or 6. So we would need to take this and multiply it by 6. The answer here is 0.13588, blah, 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 blah. This is her probability. And that's so much better. So much better. She had a 2% chance and then a 2% chance, but now she's got like a 14% chance. She's going to be a great magician. Consider the table. Find the average x value. Find the average y value. Stat. Edit. Oops, I already got these typed in. Wonder who made the quiz. Here we go. 4.6, 5.2, 6.7, 8, 9.1, 1, 2, 3, 4, 5, 6. Double check my math. My eyes hurt, please. Oh my god, let me go to that. Okay. Stat, calculate, two variable statistics. X bar is equal to 6.166, repeat. Y bar is equal to 3.5. Find the correlation coefficient. Stat, calculate, ln reg. Nice, that's really good. 0.9955. Sheesh. Use your calculator to find the regression equation for the data below. It says below, but I guess it means above. Then use your calculator to find the y value that corresponds to the average x value from part A. Okay. So I want to do stat calculate ln reg store into y1 calculate stat plot on zoom stat. Then I want to find the y value that corresponds to the average x value. So I could either do something like, I probably just want to go to my table and just start it at 6.166666666 and then just see what I get. And what I get is 3.5. What do you notice about the answer for D? It is 3.5. But here's what's going on. My regression goes through average x, average y, x bar, y bar, coordinate, like it always does. Smiley face. Basically, I know that the regression line goes through the average x and the average y. And so if I look for where is the average x, it is at the average y. No surprise that these are the same. In fact, if I was really maybe not so sleepy or not pretending to not know the answers, I could have just gone straight to 3.5 and got it. That's it. I apologize for the lousy quality of this video. Have a good weekend.